In this video, we're going to talk about product variety and quality under monopoly. So if you think about firms out there in the world, almost every firm that exists out there sells multiple products. So if you think about auto manufacturers, any particular auto manufacturer is going to sell a tremendous variety of cars, mid-sized vehicles, trucks, industrial vehicles, all different kinds of products. And within each product, there's going to be different levels of quality that you could select. So for a particular model of car, you would be able to select lots of different attributes of that car. If you think about a firm like Kellogg's that sells breakfast cereals, they sell a tremendous variety of breakfast cereals. And then there are other businesses like Procter & Gamble that sell lots of different types of things like shampoo and toothpaste and a whole variety of things. So what we want to talk about is the level of variety that a firm should offer. So we're going to think about, in order to maximize profit, how many different types of products should they offer? And we'll also think about whether or not that's the right amount of product variety from society's perspective. So in terms of maximizing surplus, does a firm operating in response to its own incentives that it faces, does it provide the socially optimal level of product variety or even quality? So there are two types of differentiation we can think of in terms of products. So we could think about the fact that consumer tastes are different. So people like different colors of things or different flavors of things, or if we're talking about foods, textures even. And there we're talking really about what we would call horizontal product differentiation. So if you're changing the flavor of a particular product, we think about that as changing it horizontally. But we can also think about it as changing vertically. So if we're thinking about a firm offering products of different qualities where consumers have different willingness to pay for a particular level of quality, then we're thinking about vertical, what we would call vertical product differentiation. What we're going to do, the way we're going to think about this is we're going to think about a spatial model, a model that thinks about consumers that are located at different places. And the fact that they're located at different places relative to where the good's being sold means that they're each going to have a different amount of costs that they incur to travel to buy the good. But what we're going to see is that this model is actually more general. So we're going to think about a situation where consumers agree on the quality of the good, they agree on its value, but they differ with respect to where they're located. So spatially they differ. So for example, we could think about maybe a particular type of pizza, maybe a pepperoni pizza, and suppose that all the consumers in the market have the same willingness to pay for that pizza, but they all live a different location from the restaurant. So if you live right by the restaurant, it costs you a different amount than if you have to pay the price and you live farther away and you have to drive to get there and back, okay? So this would be a situation where we're thinking about the good being differentiated across consumers by their geographic location. What we need to do is we need to think about a firm and its decision of where to sell the good. If you've got consumers that are spread out, where does the firm put the store, the location that it's going to sell the good at? And does it sell it at one location or does it sell it at 2 or 10? We need to think about that, and we're going to think about it using a model that was developed by an economist named Hotelling. And Hotelling developed the model in 1929, so this model is actually nearly 100 years old. And in my opinion, it's a pretty ingenious way to look at product differentiation. We're going to be thinking about geographic location as the thing that differs, But what Hotelling said was, and what it's clear from the model, is that it doesn't have to be geographic location. It can be any other attribute about the product, and that's what makes the model actually very useful. Hotelling talked about using the model to think about, the example that Hotelling used was apple juices of a different level of sweetness. So if you think about maybe a juice that is being sold that's very sweet, and maybe one that's kind of medium sweet, and one that's not sweet at all, maybe it's kind of sour, then consumers have preferences across sweetness, and so you might desire a level of sweetness that's very far away from the sweet variety. Or you might like yours very sweet, and so that sour end of it, that's very far away from you or your preferences. So Hotelling made it clear that this model could be used. It's easiest to understand the model if you think about it in terms of geography, but it can be used for any product attribute. And the distance in that case would be your distance from the consumer's preferred attribute. Okay, so your distance in terms of utility, or the satisfaction that you get from consuming the good. If you consume a good that's very close to what you like, then you don't have to travel very far. You get a lot of utility from that. But if you have to choose a good that's quite a bit of ways from what you actually like, the cost there is in terms of the utility or satisfaction that you get from the good. So we're going to think about a town. And this town is going to be a little bit unusual in the sense that it's going to be spread out along a single road. We can represent that road like that, where we think about this address as being the address 0 and this address as being the address 1. And our consumers are going to be spread out. The town is just a long town, and our consumers are spread out evenly across this road. There's going to be end consumers. So we have end consumers, and they are going to be spaced out equally. So they're all spaced out equally from 0 to 1. Now, if we're thinking about a monopoly, a firm that's going to be selling to these consumers, then we have to think about where the firm is going to desire to put its location. Where is it going to put itself? We're also going to have to think, as I said earlier, about how many locations. Does it put a shop here and a shop there, or maybe one in the middle, or maybe 5 spread out equally, or maybe 2 down here and 2 over there? We have to think about that. And then we also have to think about what price do they charge, right? Are they going to charge the same price at all of the locations? Is it going to be a low price? Is it going to be a high price? We're going to think about transportation costs. So the transportation cost, we're just going to call T. Transportation cost is going to be T. And we can think about that as a round trip cost. So if you live here and the store is located over here, you have to travel to the store to get the good and then travel back. And that traveling there and back costs you some portion of T. It depends on how far away from the store you are. So we'll talk about that here in just a second. Except for the location, the consumers are going to be identical to each other. So they all place the same value on the good that the firm is selling. We also want to simplify this by assuming that each consumer is going to buy 1 unit of the good. And that makes it simple because we don't have to worry about a demand curve for each consumer, because as long as their willingness to pay is higher than the price, they buy the good. And if their willingness to pay is lower than the price, they choose not to buy the good. So that makes it a little bit easier. Let's talk about the value that consumers place on it. So we're going to call that value, we're just going to call it V. Now you can think about that as if we were thinking about a demand curve, you could think about that as the choke price. So if we had an inverse demand curve, The intercept of that demand curve would be the highest price that the consumer is willing to pay for the good. Again, if you're talking about a demand curve, we're thinking about the consumer as being willing to buy different quantities, but here it's just going to be a dollar amount. So maybe the dollar amount is $10. Okay, the consumers are willing to pay a maximum of 10. If the firm is charging a price plus transportation cost that's less than V, the consumer buys it. If the price plus the transportation cost is higher than V, the consumer does not buy the good. So a lot of times we call this the reservation price. So I may call it that reservation price. I may call it the choke price. I may call it the value. It's the same, all the same thing. So now let's start by thinking about the monopoly operating one location. And it's probably reasonable for you to think about them putting that location right in the middle. Okay, we'll talk more about that here in just a little bit. But let's suppose they do. Let's suppose the monopolist operates one location and it's located halfway. Again, you can think about this as the address. So here's 0, here's 1. They're going to locate their store at address 1/2. We're going to put an axis on each end, and we're going to measure the price along that axis. So vertically, we're measuring price here. We can also think about, in terms of dollars, where their reservation price is. And so we're going to put that, I'm going to put right up here, let's suppose there's V. That's the maximum amount that consumers are willing to pay. And I'm going to extend a line across here, and we'll put V on the other side. There's V. So the height of that line represents the consumer's willingness to pay, all consumers' willingness to pay. So these consumers down here are willing to pay V, and these consumers up here are willing to pay V. All of them are willing to pay V. Now, the monopolist is going to set a price, and we can call that P1. I'm going to draw a little line here to indicate the height of that price, and it's going to be P1. So the monopoly will choose that price. Now, clearly, they're not going to want to choose a price that's above V, because then nobody would buy the good. So they have to choose a price that's less than or equal to V. And the fact that almost every consumer is going to have to travel and incur the cost of travel, that means they're going to need to choose a price that's below V. Okay, so we're going to think about X. Let's let X be the distance from the shop. Distance from the shop. So X is just how far the consumer is from the shop. Okay. Now, what that means is that the full price that the consumer pays when they buy the good, the full price would be the price they have to pay to the monopoly, P1, plus they're going to have to pay some portion of the cost, and it's going to depend upon their distance that they are from the shop. So it's going to be X times T. Now, if we add that to the picture, here's what that's going to look like. Remember, the consumers are spaced out evenly. So if you're a consumer that's right here, right at the location of the shop, the only price that you pay would be P1. But as we start to move out, the consumers are going to be paying more and more, and we can represent the full price that they pay with a line that looks like that. As we move further away from the shop, their cost, the full price that they pay, goes up. And the slope of that is going to be dependent upon T. Okay? And it doesn't matter if you live out here or if you live in this direction. As we move either direction, the full price that the consumer pays would be P plus their travel costs. So I'm going to add that as P plus, I'm going to write it this way, T times x, and then p plus t times x. So that represents the full price that consumers pay. Remember that x here is just a fraction of a mile, okay? I'm going to put a little dotted line right here and then call that x1. I'm going to also call that x1. So remember, these are just addresses. Any consumer that lives to the left of that x1 right over here does not buy the good, because the price they would have to pay is greater than their reservation price. It's more than they value the good. Only the consumers located in this region would be the ones that purchase the good. And again, consumers in this region, it would cost them, in terms of the full price that they pay, more than they value the good. So they choose not to buy the good. Now let's talk about how x1 is determined. If we wanted to solve for x1, remember that the consumers that live right at x1, they are indifferent between buying the good and not buying the good, because the price that they would have to pay, the full price that they would have to pay right there, is equal to the value that they place on it. The same for a consumer that lives right here. Okay, so now we can use that to figure out x1. We know that their reservation price is equal to the full price. Their reservation price, which is V, is equal to the full price that they would pay, which would be P1 plus T times X1. I'm going to, let's put P1 there. I'm going to subtract off, I'm just going to solve for X1. So this would be V minus P1. And then x1 is equal to V minus P1 over T. Now here's what we can say. Remember, this is the location of the consumers who are indifferent between buying the good and not buying it. If we were moving from the middle out, it would be the last consumer that buys to the west and the last consumer that buys to the east of the store. Okay? And what we can say there is that if V goes up, since it's in the numerator, if V were to go up, that would increase x1. It would move this range higher. And you can see that visually, because if we moved V up, then this range of buyers would get bigger. So that makes sense. On the other hand, if we increased P1, the range would get smaller. So if we were to increase P1 in this direction, then clearly that V would move up and that range between our x1s would get smaller. So if the firm charges a higher price, they'll sell to fewer customers. That's not surprising. And then if T were to go up, what we can say is that x1 would go down. And that makes sense, because if T were to go up, the V would start to close up more like that, and the range would get smaller. So that makes perfect sense. Let's talk about the number of consumers that buy. So how many consumers buy? Let's ask that question. How many consumers buy? So remember, there are n consumers, right? We've got n of them, and x1 is just a fraction of a mile, right? So the number of buyers would be equal to twice this amount, right? It's going to be 2 times x1 times the number of consumers there are. And if that doesn't make sense yet, we're going to do a numerical example here in just a second, and I think that'll make perfect sense as soon as you see, as soon as we put some numbers to it. So there's the total number of buyers. Now, we know that x1 is right here, so what we can say is that total demand, which I'm going to write this way, I'm going to call it Q. It's dependent upon the price that the good charges, which we're calling P1. And I'm also going to say that in this example that we're doing, we've only got one firm. Here in just a bit, we'll think about what happens if they have two firms, and then that'll be a 2. But right now, we're thinking about total demand if the firm charges price P1 and has one location. And what that would look like is I'm going to write this, but I'm going to plug in my x1 there. So it's going to be 2v minus P1 over t times n. And then I'm going to just do a couple of things to that. I'm going to say that that is 2n over t times v minus P1. So there's the total demand. So the first thing we can recognize is this: even though all of our consumers are identical, every consumer is identical to every other consumer, they all value the good the exact same amount, and even though each consumer either buys or doesn't, what we see is that as P increases, quantity demanded declines smoothly. Right? Fewer consumers are willing to buy the good. And that makes sense because as we increase P, if we were to take this thing and move it up like that, then our Y would move up, and this range of buyers would get smaller and smaller, and it would be a smooth transition. So even though there's a lot of discreteness in this model, you either buy or you don't, and every consumer has the exact same willingness to pay, we get this smooth relationship between the total demand, quantity demanded, and the price of the good. Let's talk about what price would make every consumer buy the good. So I'm going to say this: at what price will all consumers buy? So clearly, it's not going to be P1. It's going to have to be some price lower than P1. We need to move P1 down, and as we do, this range is going to get bigger and bigger. And what we want to know is how far do we have to move P1 down before X1 moves out to that point right there. So what we need to find is the price that would make our consumers that are located at addresses 0 and 1 indifferent between buying and not buying. Those consumers, 0 and 1, are each located 1/2 mile from the store. Okay? Remember, these are fractions of a mile. But if we start right here and we move this direction, then that person at this address would be 1/2 mile from the store. Same with the person at that address. So their price, so at the ends, the price for those consumers would look like this. The price would be, because they're each 1/2 mile, their price would be P plus T divided by 2. Now they're only going to buy, they only buy if that price is less than or equal to their reservation wage. So they only buy if P plus T divided by 2 is less than or equal to V. So I'm just going to move that T over 2 to the other side, and I'm going to denote that price this way. I'm going to say the price where end consumers buy and the firm has one location. So it's similar notation to what I'm doing right there. It's a little bit different, but the price that results in end consumers, all of them buying, would be V minus T over 2. That's the price at which every consumer buys a unit of the good. Now let's put some numbers to this, and I think it'll help you kind of solidify in your mind what's going on with this model. So let's suppose that V is equal to 20. So that's the value that consumers place on the good. Let's suppose that we have 100 consumers. Let's suppose P1 is equal to 15, and let's suppose our travel cost would be 20. So if we think first about demand, we can think about this. We've got everything we need right there. We could say that the total demand, if we've got a price of 15 in one location, is equal to 2 times 100 divided by 20. I'm using this version of it, and it's 20 minus 15. That's my V minus Pn. It's equal to 10 times 5, which is equal to 50. 50 consumers buy. What's going on in this particular situation is, if we were to, let's draw our picture right here. I'll draw a smaller version of it. So we've got our firm right here. We've got our value up here at 20. The firm has set a price right here at 15. I'm going to put a dotted line right there. So there's 15. And what we've got, remember our firm is at 1/2. Half of our consumers are buying, so what's going on is we've got something that looks like this. And that point is 1/4 and 3/4. This distance right there is 1/2 of a mile. Remember, because we're covering half of the space, our consumers are spread out equally. If we solve for x1, x1 is equal to, somewhere I've got my formula for solving for x1, it's 20 minus 15 over 20 is equal to 5 over 20. It's 1/4. So x is 1/4. Let's ask this question. What price makes all 100 consumers buy? Can easily solve for that. It's going to be right down here. That's going to be P. It's the price where their full price, P plus 20 over 2, is less than or equal to their value, which is 20. P plus 10 less than or equal to 20. So any price less than or equal to 10, in fact, the firm would want to charge a price of 10, that would make all of them buy. So if our price were down here at 10, right there, then these would extend out. It would end up looking like this, where we hit right there at the end and right there at the end. That price of $10 would result in all of the consumers buying. What we want to do now is we want to think about how many firms the monopoly is going to want to have, how many locations. So do they want one location and a price where all the consumers buy, or do they want 2 locations? Before we do that, keep in mind that this vertical distance right up in here represents consumer surplus for the consumers who buy, right? So if you're a consumer that is right here at the same location as the store, then you pay this price, there's no travel cost. Here's your value, and then this distance right there, that's the consumer surplus that you get. Consumers that are farther away from the store and still buy get smaller amounts of consumer surplus. These people, of course, don't buy. So what the firm wants to do, obviously, is the firm wants to capture as much of that consumer surplus as they can. So now the firm's got to decide, well, do we do 1 firm, or do we do 2 firms, or do we do 10 firms? So that's what we're going to think about. I'm going to clear this off, and then we'll come back and take a look at that. Let's suppose that the marginal cost for the monopoly is C. So marginal cost, we're going to designate as C. And let's suppose that the firm, if it adds a new location, has a setup cost. So this would be just like some fixed cost, setup cost of F, where F is standing for a fixed cost. That could be the cost of buying the site or building the building. What we can do is we can write profit for the firm. So let's write out what profit would be. Profit, we're going to use similar notation. If the firm sells to all N of the consumers and they have one location, let's write what profit would be. Profit would be the number of units they sell, N, times what they make off of each unit. And what they make off of each unit is the price that they charge, which would be P, the price where they sell to all N of the consumers with one location, minus their cost. Okay, so that's the difference between what they get and what it costs them. You can think about that as the money they make per unit, and then multiply that by the number of units that they sell. And then we have to subtract off F, what it costs them to set up the store. Okay, so we can write it this way. I'm going to substitute in for what P is. It looks like this: N V minus T over 2 minus C minus F. Okay, so there's what profit looks like if they sell to all N consumers and they operate one store. Now, we can already say that the firm would want to put that store in the middle of the street there. Because if you think about starting at the middle, where the firm is selling to all N consumers, if the firm were to move the store a little bit to the east or a little bit to the west, they're not going to capture, let's say they move it to the east, they're not going to capture any more customers out there because there are no more customers. And so they're going to lose some customers on the west end, and they're not going to capture any on the east end. So they would never want to move the store to the east. And by the same logic, they would never want to move it to the west. So it's probably pretty intuitive to you that they would want to locate that one store right in the middle of the street. Let's think about where they would want to put the stores if they now had two. Okay, so we've covered one store. Let's suppose they open two. Two locations. Now, remember that each segment of the street is the same. Our consumers are spread out evenly across down the street. Each shop is going to have the same costs. So price is going to be the same at our two shops. If there was cost differences, then that would lead to maybe differences in price. But the monopoly is going to locate those shops to where it can charge the highest price. The two shops can charge the highest price and still serve all of the customers located along the street. So what we're going to get is a situation that looks like this, where we've got, I'm going to put 1/2 right here in the middle, but it's probably pretty intuitive to you also. I'm going to put V up here. There's V. They're going to locate their stores at 1/4 and 3/4. I'm going to put a dotted line right here, and they're going to select a price in each store that would still allow them to sell to all of the consumers located in their segment. So we're going to get a situation that looks like this. Now, with this setup, the most that any consumer would have to travel to get to a store would be 1/4 of a mile. This consumer would have to travel 1/4 of the mile to get there. A consumer right here could travel in either direction 1/4 of a mile and get to a location. This consumer right here could travel 1/4 of a mile and get to that location. So the highest price that the monopoly would charge to sell to all of those consumers, if there are two stores, would be V minus t over 4 now, because the highest distance that anybody has to travel is 1/4 of a mile. So the value minus 1/4 of the travel cost, that's the highest price they could charge. That's this right here, v minus t over 4. That's that point and that point. They're going to charge the same price in the two locations. And our profit now would look like this. Profit, if the firm sells to all n of the consumers with 2 locations, would be equal to n times v minus t over 4 minus c minus 2f, because now they have to set up 2 locations. So it's very similar to this, except our cost of travel has the number of locations affects how much the travel cost is going to be for any particular consumer, or the consumers on the end, and we have 2 of these setup costs. Now, if the consumer were to operate 3 stores, let's take a quick look at what that would look like. So if we had 3, then here's what's going to end up happening. I'm going to put 1/2 here. So essentially they're going to space these 3 firms, these 3 locations out equally. So our firms are going to be located here at shop 1 is going to be right here at 1/6. Oops, that should be 1/6. There's going to be a shop firm at 1/2 and a firm at 5/6. I'll show you where those come from here in a second. Let's put our V up here. So here's V. And we're going to have a firm here, a firm here, and a firm here. And what that does, I'm going to put a dotted line right here, that separates the market into 3 chunks with a location in the middle of each chunk. Okay, so this firm would be selling to these consumers over here. This one would be selling to these consumers in that middle section, and this one would be selling to these consumers in that east end right there. Now, if you think about it, the maximum distance that any consumer has to travel to get to a location is 1/6 of a mile. And we're starting to see a pattern here. That's why we're going, increasing the number of locations by 1 each time. The price now, the highest price that the monopoly could charge and still sell to all end customers with 3 locations is now v minus t over 6. Because the highest distance anybody would have to travel is 1/6 of a mile. And profit now would look like this. Profit, if they're selling to all end consumers with 3 locations, is the number of units they sell to, which is n, v minus t over 6 minus cost minus 3f. So you start to see this pattern emerge, and what we can do is we can say that if we think about n firms, if we had a monopoly that's operating within locations, those locations would be at these distances: 1 over 2n, 3 over 2n, 5 over 2n. I'm going to skip a little bit. Let's go just do the ith one. 2i minus 1 over 2n. We'll skip a little bit more and we'll do the nth one. The last one, it would be 2n minus 1 over 2n. So let's think about n being 1. Suppose the monopoly is going to operate 1 location, then n's 1, it would put it at 1/2. If we plug in n over here, we get 3 over 2. Those are all greater than 1. So if n is 1, the only one we need to think about is this one. But now let's make n 2. So they're going to operate 2 locations. Well, then they would put one at 1/4 and one at 3/4. That's right here. Or if they were going to operate 3 locations, they would have one at at 1/6, one at 3/6, that's the 1/2, and one at 5/6, that's right there. And we could think about it in terms of 10 locations or 100 locations if we wanted to. And these are all going to be locations from the left end. From left end. In this case, the maximum, in the nth case, the maximum amount of distance that anybody would have to travel would be 1/2n miles. Our price, if they sell to all end consumers within locations, would be V minus T/2n. That's our general form of our price. And then profit, we can write generally for n locations, would be capital N consumers with little n locations. It would be N V minus T/2n minus C minus N times F. The number of locations they have multiplied by that setup cost. So let's take a look at these. Let's start with price. Here's our choke price. So what we can see is that as the number of locations goes up, the price gets closer to the choke price. As the number of locations goes up, these start to move up, right? If you envision this one and instead of 3 firms, there were 4 or 5 or 10, we would see these prices rising. And what happens is that the area that is representing the consumer surplus would be getting smaller and smaller. So as N goes up, this denominator gets bigger and bigger. This thing goes to 0, and the price is getting closer and closer to that choke price or the reservation price. And as I said, the monopoly is capturing more and more of the consumer surplus. Now keep in mind, let's review that we talked about the fact that we're thinking about this in terms of geography, physical geography, but it's a more general model than that. You can think about this as any product attribute. You can think about it as a particular level of salt in a food, or a particular level of sweetness, or a particular amount of sugar in some diet drink or something like that. So this, again, it's easiest to wrap your head around if you're thinking about it in terms of physical distance, but it's much more general than that. Kind of the bottom line to this, one of the important points is that the firm is setting up multiple locations, which we've talked about in the past as being related to scope economies, but there's no scope economies here, right? C is not changing. If C were going down as they opened up multiple locations, then there are scope economies, but that's not happening here. So even without scope economies, the monopoly is going to have an incentive to offer lots of varieties of the good. Okay, so this helps us understand why we see firms offering multiple varieties. And they can charge a higher price for the good because each particular variety is now closer to some particular group of consumers' preferences. Now let's talk about this. What limits this? There has to be some limiting factor, or else the firm would just set up a limitless number of locations. We don't see a Taco Bell on every street corner, so there has to be something that puts a cap on this. So let's look at the statement of profit. Remember, I'm going to write it again. The statement of profit looks like this. Within locations is equal to capital N V minus T over 2N minus C minus N over F. Now, let's suppose that the monopoly opened one more location. So let's think about the profit of that N plus 1 store. So if we had now the profit where they sell to all N consumers, but they're opening an N plus 1 store, it would be N V minus T over 2. This would now be N plus 1 minus C minus n plus 1 times f? Well, it's only profitable to operate that n plus 1th store if, so it's only profitable if the profit, obviously from the n plus 1 store, is greater than the profit from just operating n stores. So that would be profitable. We can plug in each of these statements right here. You can do some algebra. For the sake of time, I'm going to skip that algebra. But we can show that this is true. This is true if this statement holds. N times n plus 1 is less than t over n divided by 2f. It's profitable to open up one more store if that statement is true. Now it's kind of hard to understand that just looking at it. Let's think about some numbers. Let's suppose that there are 5 million people in a particular market. And let's suppose that the setup cost is $50,000. And let's suppose travel cost is $1. Then that means that if we plug those in right over here, that means that this is equal to 50. So if n times n plus 1 is less than or equal to 50, then it's profitable to open up another store. So if n is less than or equal to 6, right, then it's profitable because you would have 6 times 7, that's 42, which is less than 50. So you would open up another store. You would open up a 7th store. But if we've got 7 stores, then this would be 7 times 8, which is 56. That doesn't fit. So given these numbers, the size of this market, we would expect to see 7 stores. If there are 6, it would be profitable to open up one more. If we ignore, so we're thinking about the number of shops as having to be an integer, which makes sense most of the time, all the time. If we ignore that, if we thought about averages, which a lot of times economists do, if we ignore that this has to be an integer, then we can solve for n, and we get this, that the optimal number of stores would be this number. It would be t square root of that statement right there. That would give you the optimal number of stores. And what we can see is that the bigger n is, the more consumers there are in the market, the more stores there will be. That makes sense. The bigger t is, the more stores there are going to be. It's in the numerator. That makes sense. T is our travel cost. The more cost consumers have to incur to get to the location, the more locations you want to have. And then the bigger f is, that's our setup cost. The fewer stores you would have, because that's in our denominator. That also makes sense. When you think about this, t, in terms of distance, we're talking about travel cost. But if we're thinking about this in terms of just a general product attribute, like the sweetness of a particular drink, then t is how far a particular consumer's preferences are away from that particular variety. So if there's only one variety, how close is it to what I would really like to have? So t is the distance in terms of your preferences in that case. Now, one thing that we need to review here, or at least talk about, is that when a firm adds a new variety, it's doesn't necessarily mean that it's increasing the total supply of the good, because what's happening is it's kind of segmenting the market, right? You're replacing some of an existing variety with an alternative variety. Let's ask another question here, and that is, well, will the monopoly actually want to serve the entire market? We've been talking about selling to every consumer. Is that something that the monopoly wants to do? If we were to look at a situation where, let's say we had a street that looks like this, and let's put up here V, so there's the reservation price, and we had a store located here at 1/4 maybe and 3/4. And let's suppose that they charge a high enough price that they don't sell to the entire market, then it would look something like this. So in that case, now you're selling to chunks of the market, right? You're selling to these consumers located right in here and these consumers located right in there. And essentially what you would have is a situation where each location would be a standalone shop. Well, in that situation, we can show that the price there looks like this, V plus C divided by 2. And the important thing to note about that is that the price does not depend on the number of outlets. You can see that the only things that it depends on are the cost, that marginal cost, and the value that the consumers place on the good. It doesn't depend on the distance. So you can see it's different there. Serving the entire market, remember earlier what we saw with in locations is this. Price equals V minus T over 2N. Right? That's a version of that right there. So serving the entire market, you want to sell to all the consumers if that price is greater than that price. We can do a little bit of algebra again. It's not hard algebra. I'm just going to skip it for the sake of convenience. That's true if this is true. If you just plug those in, do a little bit of algebra, you'll get that. Here's what it says. If the value that consumers place on the good is greater than your marginal cost plus the travel cost, then supply to the whole market. If, on the other hand, the value that consumers place on the good is less than your marginal cost plus the cost of travel, then supply to only part of the market. Let's finish up by thinking about that last question that we talked about, and that is there the right amount of product variety? So, does a monopoly have an incentive to provide too much variety? You can do some algebra. I'm going to skip it. And you can show fairly easily that the number of firms or the number of locations that maximizes total surplus looks like this. I'm going to call it N star. It's equal to this T times N divided by 4F. That's the number of firms that would maximize total surplus in the market. The firm finds it profitable to add another location if this is true. So if you compare these, you can see that the denominator is bigger for the socially optimal level than it is for the level of firm level that the firm has an incentive to provide, which means that the optimal amount of variety, or in the distance case, the optimal number of stores is less than what would actually be provided. I called that N star, and that's N star. Let's put a different star there to distinguish. There's the level that maximizes total surplus. Here's when it's profitable for a firm. So what we can say is, yes, the monopoly does indeed have an incentive to provide too great of a level of product variety. So I hope that gives you some idea of the incentives that a firm faces that leads to multiple locations or product variety. I'll see you in the next video.